Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the second video in my series on threads. And in this one, we're going to create and run some threads. Let's just jump right into the code. Here we are in Visual Studio, and as you can see, I've set up a little console app for running our test code. I've also got a class here called Simulated Jobs. We are going to be running some worker threads and we need some work for them to do. So I've got two kinds of work we can play around with. One function is do something blocking, and the other function is do something CPU intensive. They're both pretty simple, and they both achieve the same goal by occupying one of our threads. Do something blocking waits for the thread. It just literally kind of puts it in a wait state. And the way it does it is with this primitive called an auto reset event, which is just like a flag. When we create it, the flag is unsignaled. And then when we wait, event wait1 waits for the flag to be signaled, and it's never going to be signaled. And then our timeout expires and the thread resumes. So this is an extremely efficient way to put a delay in a thread. And we're going to use this in a later video when we construct a very efficient polling loop. Do something CPU intensive is kind of funny. I wanted to actually cause the CPU to have to think. So what I did was I initialized a string here with the first line of Jabberwocky. Then we start looping. And in each loop, we calculate a hash of the current string. Then we concatenate together the hash string and the first line of Jabberwocky. And then we do it again. And it just so happens that on my computer, 700,000 loops comes out to about a second. So this will keep the CPU busy. Both of these are examples of what is called CPU-bound work. And this one is just very precise and efficient, and this one is a little more approximate, and we'll be able to watch the CPUs actually work. Okay, so the next thing I've got for you is a class called threadTest, and the first function we want to do is run one thread. So let's go ahead and implement this now. And what I'd like to do is log some messages. So when I log messages in this app, I'm using a little class called FancyLogger. And you'll see what it does. It does some fun color coding and formatting for us. So FancyLogger.log, and we'll say that we are entering run one thread. And when this function exits, I would also like to know when that happens. So in the middle here, we need to create our thread. So we'll say thread t equals new. And now we're calling the thread class constructor. And we're going to pass it one of two delegates. We can either pass it a parameterized thread start or a thread start. So I'm going to go with thread start. So we're going to put that right there. There are really three ways we could implement this. We could use a named delegate, we can use an anonymous delegate inline, or a lambda function inline. Now, if you're not familiar with those differences, I have a nice tutorial in my C# language features you should know about series. It's called Delegates versus Lambda Functions. So go check that out if you want a little more info. For these examples, I'm going to use named delegates. I think they are nice and clear. So we'll do private static void threadproc. So this function, threadproc, meets the definition of a thread start delegate. Basically just a function that returns void and takes no parameters. That's all there is to it. So we can go ahead and call this constructor passing in threadproc. And then we're going to do t.start. Now I'm going to do one other small thing, which is I'm going to put in a small delay here. And this is really just to help out my fancy logger. The color coding works better if we have slight delays in certain places. It's not really necessary for the demo. After we start our thread, I'm going to put in t.join. So when we join a thread, it means we're going to wait for it to finish. So this is actually going to block our main thread until the worker thread finishes. So what do we want to do down here in our actual thread procedure? Well, let's say we're entering the thread proc, and we can say we are exiting the thread proc. And right in the middle, let's do one of our simulated jobs. We can do something blocking for 3 seconds. Okay, I think that's what we need. So at the program level, we'll say thread test, run one thread, and that should do it. Let's kick this off and see what happens. Welcome to the Thread C# demo. Press enter to start. So we've entered our run one thread, then we entered our thread proc. We started something blocking. We waited 3 seconds and finished something blocking. Then we exited the thread proc and we exited our controller function. And as you can see, the controller function, run one thread, it was running on our main thread, which happened to be assigned managed thread ID 1, and Fancy Logger gave it the color blue. Then the worker thread got assigned managed thread ID 12, and Fancy Logger gave it yellow as a color. So there we go. We ran one thread. Why don't we do several of them just for fun? Let's run several threads. So we can go back to our thread test, and we can say public static void run several threads. And we could pretty much copy this code, except we are going to put this inside of a loop. And we do not want to join, and I do want my little delay. Now 10 threads is probably too many. Let's just start off with 3, just for the sake of argument here. So run several threads is going to do the same thing that run one thread did. It's just going to do it 3 times, and it's going to start 3 different threads. And notice they are all using their own copy of the same thread proc. So it's really 3 copies of the same work. All right, let's go back to the program, and we'll change this to run several threads. Let's see how this looks. And here we go. We'll wait for it to finish. All right, very nice. So on our main thread, we entered the run several threads procedure. Then we launched 3 threads. One of them is on managed thread ID 11, one on 12, and one on 13. And they all began doing something blocking. Now this is interesting. We have another blue line here. Why? Well, that's because we didn't join on these threads. We basically started them and we let the main thread keep running. And that's actually what you almost always want to do. Blocking the main thread while your worker thread runs is kind of counterproductive. Then, after about 3 seconds, we can see that all 3 of our worker threads ended. So the last thing I want to show you here is what happens if inside of our thread test, instead of doing something blocking, we do something CPU intensive. And in this case, why don't we pump it up to 6 of them? and see what happens. So I'm going to run this. And right before I click enter, I'm also going to bring up my process monitor. Oops, nope, wrong one. Performance monitor. So here is performance monitor, and this is showing you CPU utilization. So let's go ahead and click enter. And as we start running these CPU intensive jobs, you can see that our CPU, I've got a 4-core machine here, it is at 90% utilization, and then as it gets through all 6 of those tasks, it drops down. So there you go, actual multi-threading using the cores, launching background threads. In the next video, what we're going to start looking at is thread data. This thread took no data in, it returned no results, but that's not realistic. Usually, you do need to handle some data. So we'll talk about thread data, and along with that, the very important concept of thread safety. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.